Question number 4. The diagram shows a potential divider circuit designed to provide a variable output PD. Which row gives the available range of output PD? This is the simple form of the circuit. So the voltage is the same. Then we have two resistors with equal value. So if we look at just the circuit, we can state that this 9-volt battery, its energy is going to be split or shared between both resistors equally, which means 4.5 volts will be across this resistor and 4.5 volts across on the other resistor. However, this is not a fixed value resistor. When we have this arrow, this indicates this resistor maximum value will be 5 kilo ohms and minimal value be 0 ohms. So it's gonna range from 0 to 5 kilo ohms. Is a variable resistor. Now we have a fixed resistor connect in series with a variable resistor. Now if I place the terminals of my voltmeter on this variable resistor, depends on the value that is set up from 0 to 5K, I will have different readings. So this is the symbol of my voltmeter, the terminals, and this is what we call output voltage. Okay, so we are going to be working with the extreme range of this variable resistor from 0 ohms to 5 kilo ohms. So if this resistor, the variable resistor, is set on 0 ohms, what will be the voltage on its terminal? So the voltmeter should be reading 0 ohms. And what happened to the 9-volt battery, the 9-volt when come to splitting between those two resistors, they are going to all here. So if I read the voltage across this resistor, I should be reading 9 volts. Okay, now this variable resistor is set on 5 kilo ohms. So what will be the voltage on this resistor when I place my voltmeter right here? Since both resistors, they are equal, of course, there will be 9 volts between both. That will be 4.5 volts. I want to make a correction here that I just noticed. This is 0 volts, not 0 ohms, 0 volts. So for 0 ohms for this resistor, I'm going to read here 0. For 5, I'm going to read 4.5 volts. We also have a formula for this one. So the output voltage, Vout, is equal to the input voltage, in this case 9 volts, over the resistor where I need to calculate my output voltage, this one. So let's say 5K ohms over the sum of the resistors in this circuit, which is 5 kilo ohms plus 5 kilo ohms. Okay, after substitution, so 5 divided by 10 is 0.5 times 9 is 4.5 volts. So either way, we can determine these results by analytical type of thinking with the circuit and understanding that variable resistors range from one number to another, but usually on this type of problems they are going to be asking just the extreme values, in this case 0 and 5 kilo ohm. So to spot the answer, the minimum output should be 0 and the maximum output is 4.5. So the answer is B. Question number 5. Which statement is not valid? So we have to read each one of those and say true, false, and that we can narrow down to the right answer. The definition of current is the rate of flow of electric charge. So here it says that current is the speed of the charged particles that carry it. Okay, so this is not correct. But let's read the next one. Electromotive force, or EMF, is the energy converted to electrical energy from other forms per unit charge. This option is correct because electromotive force, EMF, converts chemical energy to other forms of energy. C. The potential difference, or PD, between 2 points is the work done in moving unit charge from one point to another. So remember that PD is the same as voltage. So voltage, the definition is the energy or unit of charge. So energy is also work done per unit charge. So this question is correct. I meant the option is correct. Option C is correct. So the last one is related to resistance. So the resistance between 2 points is the PD between the 2 points per unit current. So by Ohm's law, resistance is voltage over current. So voltage here, in this case, will be our PD between 2 points per unit current. So D is also correct. So the only statement that is not correct is A. Question 6. A potential divider consists of a light-dependent resistor, LDR, in series with a variable resistor, R, and the resistance of the LDR decreases when the light level increases. The variable resistor can be set as either high resistance or low resistance. Which situation gives the largest output voltage? So in this circuit, both resistance, they are not fixed. So this resistance depends on the amount of light. And this resistance has a range from minimum to maximum value. So both resistance, they are not fixed. So by our results, we can look here the amount of light at LED and how the variable resistance is set on high or low. So we need to look individually to determine each one will produce the largest output voltage. This is the graph for the light-dependent resistor, or LDR, with its between the resistance and the light intensity. So as you see here, if it's dark, so the resistance is high. If the light is getting brighter, so the resistance is low, which means that when it's dark, this LDR has the highest resistance. In other words, that's how the LDR can be summarized. When it's bright, so the LDR has a low resistance. and when it's dark, the LDR has high resistance. So now let's take a look on the voltage provided. So the voltage is fixed. It needs to be shared between both resistors. So what the problem is looking is the output voltage, the largest output voltage on this variable resistor. So what will be the condition for the LDR and for the variable resistance to provide the largest output voltage? So let's take a look on the resistance of a LDR with the amount of light. So if the amount of light is high, so the resistance is low. And this is also low. When the amount of light is low, so the resistance of the LDR is high. High and high. So in order for this output voltage be greater here, so my LDR resistance must be low. So it's gonna be low, and one of those two options here, A or B, when the light level is high. So this is eliminated. Okay, so high or low? Well, for this resistor, draw lots of energy from this battery, need to be really high here. So the energy is gonna be more in this variable resistor. So should be high. So this option for the LDR, high level of light, and the resistor set on the highest range will produce the largest output voltage. So option A is correct. Problem 7. Two electrically conducting cylinders, X and Y, are made of the same material. Their dimensions are as shown here. The resistance between the ends of each cylinder is measured. What is the ratio between the resistance of X over resistance of Y? Choose the correct approach. We need to see what the dimensions are given here. The length, cross-section area of the cylinder, and stating the statement of both are made of the same material, which sounds like rho or resistivity. So we are using this formula. The resistance, that's the formula for the definition of resistance, is equal to resistivity times the length of the conductor over the cross-sectional area. Okay, so resistance of X and Y right here, and the formula is the same for both. Now, because they have the same material, you can already cross this guy right there. Now, let's look at this first. What is left is L over A, L over A. The L is for X, the L here is for Y, the A is for X, and the A is for Y. So what I did is, this is a fraction over a fraction. So I kept the fraction on the denominator the same. All this is related to the X. And then I flip the fraction on the denominator. Now I have A over L, and everything here is about Y. Okay, I'm going to complete this showing what the diagram is providing. So this is X and this is Y. The L for X is just L. It's uppercase, but I'm using lowercase, which is fine. The area is, we have the option for area is pi over 4 d squared. Okay, that's one option. Also, we have area is pi r squared, but r is diameter over 2 square. So squaring both, that's how I got pi over 4 d squared. So d here is uppercase in this case. Well, so now we have on the denominator pi over 4 d squared. Now on y, the area here is 2d, so that will be pi over 4 instead of a single d. Now it's 2 times d, all this square. And the length of y is 2l. Now I'm going to cancel things out. This with this. And L with L. Let's see what is left. So I'm moving this here because I have more space. So this is, here is 1 over what is left here, d squared. And what is left on this is 2, okay, let's do this, 2d squared over 2. Okay, so now we can do this. Our x over our y is, you can cancel d squared with d squared, but 2 here is also a square, so we have 4 over 2, and this is equal to 2. So that is the answer right here, A.